This is Mr. P, and today we're going to learn about the law of cosines. And to do that, we're first going to prove the law of cosines, and then we're going to see how we can use it in an example to solve triangles. Now, we're going to take a triangle ABC. It can be any triangle, doesn't have to be a right triangle. And in the plane, if you translate or rotate a triangle, it doesn't change any of the side lengths or any of the angles. So we do have that freedom to position it uniquely. So what I'm going to do is I'm going to position our triangle so that point C is at the origin and the side A goes along the x-axis. So I'm going to position our triangle like this. And a couple of things we can observe from this. First of all, I do want to drop a perpendicular from point A to the x-axis. And then I'm going to talk about point A in terms of this distance here, which this distance from point A to where the perpendicular intersects the x-axis, I'm going to call that x. And then the distance of that altitude, I'm going to call that y. So therefore, as far as point A is concerned, the coordinates of that point would be x, y. So x comma y are the coordinates of point A. And next we're going to look at the coordinates of point B. Well, that's just straight along the x-axis, a distance of a units, because a is the length of the side. So for point B, the coordinates would be a comma 0. It doesn't go up or down from the x-axis. Once I can represent points A and B with those coordinates, then I'm simply going to use the distance formula between the two of them, and that I can manipulate to arrive at the law of cosines. So if we look at the distance formula, we're going to say that length C is going to be the square root of the sum of the squares of the differences in the x-coordinates and the differences in the y-coordinates. So our x-coordinates were x and a, so I take the difference and I square it. Our y-coordinates are y and 0, take the difference and square it. Sum the squares, take the square root, and then that will be the distance from A to B, which is the same as the length of side C. Now a little bit of algebra. We're going to square both sides. That gives us c squared equals this expression. And then I'm going to expand this binomial squared. But before I do, I'm actually going to make a substitution here. What I want you to do is consider this right triangle here. If we look at this right triangle, then I can represent x, since it is the adjacent side with respect to angle C, I can represent x as the hypotenuse times the cosine of the angle. So x is equal to b cosine C. Likewise, the y is the opposite side with respect to angle C. So that's simply going to be the hypotenuse again times the sine of the angle. So y would be b sine C. So I'm going to make those two substitutions for x and for y, and then that would give us this equation here. So instead of x, we now have b cosine C. Instead of y, we now have b sine C. And now I'm going to expand the binomial. So we're going to have c squared equals b squared cosine squared c minus 2ab cosine c plus a squared. That is the binomial here expanded. And then the second term, when I square that, I get the b squared sine squared c. Now, cleaning this up a little bit, I'm going to bring the a out to the front. And then I have a couple of terms that have the b squared. So I'm going to group those two terms together and factor out the b squared. So it's b squared times sine squared plus cosine squared. And then I still have this term here, the minus 2ab cosine c. Well, you might notice that the sine squared plus cosine squared is 1. So if I make that substitution, then I have c squared equals a squared plus b squared minus 2ab cosine c. And that is our law of cosines. Now, if we look at when to use the law of cosines. Let's start with those properties. Officially, we want to use the law of cosines to solve oblique triangles when you have either side angle side or side side side. But sometimes a lot of students get confused of when to use law of sines, when to use law of cosines. I think the easiest way, rather than memorize the different congruency schemes, is to think of if you know an angle and its opposite side, if you know that angle and side pair, then you can use the law of sines. Otherwise, you must use the law of cosines. Now, the law of cosines, notice in our example, we used angle C to derive that. You could have used either the angle A or the angle B. This means there are actually three versions of the equation, and I'm going to show them to you here. And for my usage, I like to use alpha, beta, and gamma rather than the capital A, B, and C, because here a capital C would be tough to distinguish between the lowercase c. So these are the three different equations depending on which angle you have. But again, rather than trying to memorize all three of these, I think a better way to look at this is to think of the idea that any side squared, so if we look at the bottom one here, a squared, any side squared of any triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the included angle of those other two sides. So the included angle between B and C is alpha. The included angle between A and C is beta, and the included angle between A and B is gamma. So this is how I prefer to memorize, so to speak, the law of cosines. The square of a side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the included angle. And one little side note is if you look at the first equation here, this works for any triangle, but let's say we did have a right triangle. So let's say C was the hypotenuse. That would mean that gamma would be 90 degrees. Well, the cosine of 90 degrees is 0, so this term completely goes away, which means you have just the Pythagorean theorem. So in effect, the law of the Pythagorean theorem is really just a special case of the law of cosines. Law of cosines is much more useful. You can use it for any triangle, whereas the Pythagorean theorem is only for right triangles. All right, now let's take a look at an example and see how we can use this to solve triangles. We're asked to solve the triangle where A equals 2, B equals 3, and gamma equals 60. So notice how gamma is the included angle between A and B, so we have that side angle side. Or you could think of it as, I know gamma, but I don't know C, so I don't have that angle side pair, so therefore I must use the law of cosines. Well, our first step in problem solving is always to make a visualization. So if I do that, here's one example of the way I could draw the triangle. As long as you draw it so these three properties are true, then you might have had your 60 over here, and this is 2 and this is 3. But it's still going to work out to be the same numbers. So I know these three pieces of information. I need to solve for these three. So I'm going to start out solving for C. That's our direct use of the law of cosines here. So for C, I have gamma, so I'm going to use the version of the formula that has the gamma in it. So we have C squared equals A squared plus B squared minus 2AB cosine gamma. And now I'm going to substitute in the values I know, because I know A is 2, I know B is 3, and I know gamma is 60. So substituting in those values, I can further simplify. 2 squared is 4, 3 squared is 9. Cosine of 60 is 1/2. And when you clean that all up, you get 7. But remember, that's C squared equals 7. I still need to take the square root of both sides, which algebraically means I would add the plus minus, but here we're talking about the length of a side, so I'm going to ignore the negative answer. So therefore, c is exactly equal to the square root of 7. I do not want to put that in the calculator and get a decimal approximation because I'll need to use that number to calculate the other angles. And now once we have the value of c, we can continue on and use the law of cosines again if we wanted to. And let's look at alpha, for example. So for alpha, this time I want the version that has the alpha as the angle. So a squared equals b squared plus c squared minus 2bc cosine alpha. And once again, we're going to substitute in the values that we know. A is 2, b is 3, and c we now know to be the square root of 7. And alpha is still our unknown, so that's what we're actually solving for. And let's give us a little room here. Alright, so simplifying that a little further, we get this, because when we do the square root of 7 squared is just 7, etc. And now we still want to isolate cosine alpha. We're solving this trig equation. So we're going to clean it up a little more, bring in the cosine term on the left side, because it was negative, bring it over to the left, it becomes positive. And then divide by the coefficient, so we're going to get cosine is 12 over 6 root 7, which we can clean up a little to be 2 root 7 over 7 when we rationalize it. And that is in a value of the cosine of alpha. Sorry. But to find alpha, we need to actually take the arc cosine of both sides, because we are solving for the angle. And if we do that, we're going to find that alpha is approximately 40.9. Now, that certainly is a way we can get our alpha, but I do want to note that once we find the value of c in that first step, then we do have a side and angle pair. So if we have a side and angle pair, we could have actually used the law of sines for the second step, which might have been a little quicker. And just for the experience, we're going to go ahead and do that. So we could have done alpha in this alternative way. And that would be, I know c is the square root of 7, so I'm going to say the square root of 7 is to 60, the sine of 60 degrees, as 2 is to the sine of alpha. Or in other words, I set up this proportion. And then a little cross multiply and divide by the coefficient. In other words, we're solving for sine alpha. You should get 2 sine 60 degrees over square root of 7, which is the exact value. And then when we take the arc sine of both sides, you're going to have the arc sine of this expression is what you're going to put into the calculator. And you will get, once again, 40.9 degrees. You will get the same answer. Now for the remaining piece of information, we need beta. For that, we could use the law of cosines, or now that we do have an angle side pair, we could use the law of sines. But since I'm trying to get you to work smarter rather than harder, you could notice that now we know 2 angles in a triangle, so that's really the easiest way to do it. Once I know that beta is going to be 180 degrees minus the 2 angles we know, then beta is simply going to be 79.1 degrees. So always look for those opportunities to work smarter rather than harder. And we're done.